So you saw from the last post that I was building a non-inverting summing op-amp amplifier for the VPIN input to add 50 volts or the equivalent of 50 volts to our 0 to 5 volt analog voltage, which comes from the voltage converter module to the MCM. As you saw yesterday, I've got a 48/50 volt isolated DC to DC converter there, boosting the high voltage by 50 volts. So that brings our pack voltage up to an acceptable, into the acceptable range. So the bench car has been working on the bench now. So I'll just give you a quick look if I can. That is the new op-amp summing amplifier circuit. It's very slightly different really from the previous one. So basically it adds our extra voltage onto the voltage coming from the voltage converter module on the VPIN, and makes it match the voltage that the BCM Fooler and BCM are seeing. Now I was faffing around a bit this morning because I'd been a bit of an idiot, and I was wondering why the voltages weren't staying in line, and it was giving me an error, giving me a 1576 voltage detection error on that side, the HV side, voltage converter side. And what I realised was that because I've got the BCM Fooler here, and I've got the MCM, and the BCM was feeding serial voltage data via the BCM interceptor to the MCM, and what happens then is that the MCM compares the voltage data it gets from the BCM with the voltage data it manages to work out for itself from its HV input and from its VPIN input. Now what was happening was I just borrowed that from one of my earlier projects, and I hadn't checked the programming in it, and that is clearly modifying the input voltage or the voltage serial data. I think that might be from my supercapacitors, which was fixed, which was a fixed voltage to get a maximum performance, which is why, unfortunately, so as soon as I tried churning the voltage up and down, this was still sending through a fixed voltage, and it caused the system to trip. So there you can see I've actually just taken it out of the equation for a minute until I get to reprogram it. So the actual voltage from the BCM is going through to the MCM, and you'll see that we have the 2 meters here. So I'm going to just set these up. So the blue meter is connected to the VPIN output from the voltage converter module, and the more accurate RMS meter here, this is connected to the switchboard to measure the actual battery voltage. So this will be the actual battery voltage, not the faked battery voltage. So remember, this voltage will be plus 50 volts, will be actually what the car is seeing. So I'm going to turn the system on. So at the moment I've got the IMA power set at 75 volts, and you'll see that that is reading 75 volts, and the VPIN is reading 1.61. So that's all being boosted by these circuits over here to give the equivalent of 125 volts. And there's no IM errors, so I'll crank it up. Let's go up to 100. So we've now got a battery voltage of 100 volts here, and the VPIN's gone up to 2.02. And if you remember looking at that spreadsheet picture I posted, that's approximately where we want to be. And this will be boosting that voltage up by the 50 volt equivalent, which is 0.84 of a volt, which it adds on with the op-amp summing amplifier in there. So we'll go up, we'll go higher. It's higher and higher. Let's see what we can get to. So if we put this up to, let's put it up to 150 volts. Now that means the IMA is actually seeing 200 volts. So that's 149.9, 2.87 there at the VPIN. That will be being boosted by 0.84 volts in the MCM with the op-amp. So the actual system will be seeing 200 volts now. I'm surprised it hasn't actually thrown an error yet, but anyway. So basically in fact it has done. It was the ABS error which you get if you don't press the the MCM doesn't see an ABS signal within the first 30 seconds or so, it throws an IMA light. But there we are, you can cancel that by pressing the ABS switch here. So there are no IMA errors. So basically the gist of it is the summing amplifier, op-amp summing amplifier, and the plus 50 volt scheme seems to work. so I don't see any reason why the car now shouldn't accept that throughout the working voltage range, and we will see what happens. So just to recap, on the high voltage side, feeding both the BCM voltage tap fooler and the MCM high voltage input, we have just added plus 48/50 volts into the system with a isolated DC-DC converter. And on the VPIN side, we have the summing operational amplifier, which is adding the equivalent of 50 volts to the voltage coming from the voltage converter module on the VPIN line. And then the other stuff in there you're familiar with. We've got the BCM interceptor, which I need to reprogram, and we've got the IMA CNC plug and play, and you can see they're all flashing away there to show they're active. So that's where we are. So some significant progress there, and it's easy to get carried away, and I'd forgotten to check the BCM interceptor, so that held me up for an hour or so while that was giving those false errors.